Welcome to our tutorial for question 17 of our weekly review. Question 17 is asking us to find missing angles that are either in shapes or in a set of lines that we're going to be given. There's some really important vocabulary that we're going to learn about this that will help us make this process a lot easier. I also want to make sure you know there's some other vocabulary that we're not going to describe today, but that apply to this situation. If you want to look that up on your own, you're more than welcome to do that. But I'm simply going to give us the basic information that we need to know in order to complete question 17 today. Our first vocabulary word that we want to know is the term straight angle. And a straight angle is simply a 180 degree line. We should already know that all lines, straight lines, would equal 180 degrees. And this is just a fancy way that we would describe that in math, and we would call it a straight angle. We also know that complementary angles are angles that add up to 90 degrees. And similar to complementary angles, we have supplementary angles. And supplementary angles are angles that, when we put together, add up to 180 degrees. We are also going to be talking about parallel lines today. And parallel lines are simply two lines that are always equidistant from each other. And equidistant just means that they are always the same distance away from each other. You might think about that as railroad tracks. They never get any closer or farther apart, no matter how far they go. And that's what parallel lines are. We're going to be working with some straight parallel lines today. Finally, we're going to see some transversals. And transversals are simply lines that intersect another line. Understanding these things can help make the process of finding missing angles much simpler. Let's go ahead and start with a nice, easy example. Here we have a straight angle, and we know that all straight angles are equal to 180 degrees. Simply knowing that that's a straight angle and equal to 180 degrees can make finding a missing angle really simple. Here I've bisected that straight angle, so now I have two angles. These would be considered supplementary angles because I know when those two angles are added together, they create a straight angle or a straight line that's 180 degrees. Because we know that, if I'm given one of the angles, I can find the other angle. Because I know that those two angles together must add up to 180 degrees. If I have one angle that's 60 degrees, my other angle must be 120 degrees. Because 120 plus 60 equals 180 degrees. Now, I'm not going to actually change the angle here, but I could apply the same process no matter what the numbers were that were given to me. Here, if I had 135 degrees, I would know the missing angle would be supplementary and would have to add up to equal 180 degrees. So my missing angle in this example would be 45 degrees. Let's go ahead and use two straight angles. Here I have what we described as a transversal. It's simply a line that crosses through another line. So we have the same straight angle that went across, but now we've bisected or intersected that line with a transversal. And again, understanding our properties of straight angles can make finding the missing angles of this really easy. In fact, if we have one of the angles in this set of lines, we can find all of the missing angles that we have. Let's start with this exactly like what we did. Moving across the horizontal line, I know that that's a straight angle. So I must have something that adds to 30 degrees that would equal 180 degrees. So I would know that my line to the left, or my angle to the left, would be 150 degrees. Because the diagonal transversal line is also a straight angle, I should be able to figure out what's underneath the 150 degrees. I know that that diagonal line is a straight angle. It equals 180 degrees. So I should be able to find something plus 150 equals 180. And that missing angle would be 30. And again, I could do that same thing on the bottom of the 30 degrees. And I could use really either of the two lines because I know I have two straight angles, and I'm going to find my missing angle there as 150 degrees. Now, hopefully you noticed that we had some connections. We have what are called opposite angles, and opposite angles are exactly what you might think. They're directly across from each other or opposite from each other. I've color-coded them here. I've got two pink angles and two yellow angles, and we know that opposite angles are always congruent. And a reminder from question 16, congruent just means they're the same. So we see that our two pink angles both equal 30 degrees, and our two yellow angles both equal 150 degrees. We know that opposite angles are always congruent. Let's go ahead and take this and apply this to a different scenario. Now I have a set of parallel lines. I have two horizontal parallel lines, and I've cut through those two horizontal parallel lines with a transversal. Now, I'm going to apply the same properties that we've done before. I've got two pink angles. Those are opposites. We just described that in the last page. Well, I also have two opposite angles underneath. And I could do my yellow opposite angles, and I could also do my yellow opposite angles. So I'm going to see some connections here between the angles in this set of parallel lines and the transversal that is there. Now I'm going to number these angles to make it a little bit easier to communicate. Here we have 8 different angles. And I'm going to notice that angle 1 plus 4 are supplementary angles. They have to equal 180 degrees. Also, angle 2 plus 3 are supplementary angles. They have to equal 180 degrees. If I go down to the bottom line, 8 plus 5 must equal 180 degrees, and 7 plus 6 must equal 180 degrees. That's using the same information that we used with our straight angle from the very beginning. We just have more straight angles or lines that we're working with. We're also going to make note of our opposite angles here and remind ourselves that angle 1 is exactly the same as angle 3, that angle 2 is exactly the same as angle 4, that angle 5 is exactly the same as angle 7, and that angle 6 is exactly the same as angle 8. Now, I'm going to pause here for just a second before we go forward, and this is the place where there's some additional vocabulary. If you'd like to find some information, I'd encourage you to search up transversal parallel lines, and you're going to find out some key vocabulary words for how we might describe these different angle sets. But for right now, I'm simply going to also tell us that angle 1 and angle 3 are equal to each other, but angle 5 and angle 7 are also equal to angle 1 and angle 3. And that's why I've color-coded them exactly the same way. So angles 1, 3, 5, and 7, or our odd angles, are all exactly the same. They're all opposite angles, and they all are equal to each other. We also know that angle 2, 4, 6, and 8 are also all the same measurements. That means that if you know one of these angles, you can find the remaining 7 missing angles just as easily as we did in the last problem. So let's go ahead and get a missing angle. Here I have angle 1 is equal to 62 degrees. Well, since I know that angle 1 and angle 3 and angle 5 and angle 7 are all equal to 62 degrees, I can simply write those in. We know they're all equal to each other. Next, I can use my supplementary angles to know that I need to add angle 1 with angle 4. Or I could think about it as angle 5 with angle 6 or angle 5 with angle 8. There's so many different ways that we can think about this problem because I have a lot of supplementary angles here. But we simply know that we have to add 62 with something to equal 180 degrees. So if I go ahead and add 118 with 62, I'm going to equal 180 degrees, which means that angle 2, 4, 6, and 8 are all equal to 180 degrees. Now, we're going to use this same information to apply to an actual shape that might be given to us. Here, we have a shape like a triangle. And there's a little bit of extra information in this shape, but we're going to start with this and think about it like a triangle. If we're given some information about our triangle, that maybe two angles inside are equal to 70 degrees, I'm going to be able to find some other information. First of all, I'm going to be able to find that that exterior angle, that means it's outside of the triangle, is going to be equal to 110 degrees because it must be supplementary or when added together equal 180 degrees. I also know that all angles inside a triangle will equal 180 degrees. This is an interior angle sum of a triangle, always equals 180 degrees. So I can find the top angle of that big triangle because 70 plus 70 equals 140. So my missing angle at the top must be 40 degrees. I also could find those missing angles in the smaller triangles because actually what we really have here is we really have a set of parallel lines with a transversal going through it. And in fact, I'm going to just draw that exterior line there in blue, and you're going to see that connection between what we just did with our parallel lines and our transversals. So we would actually see that those interior angles of the smaller triangle would also equal 70 degrees. And that's because those are similar triangles. It means that their angles have to be the same and their sides have been multiplied by a common scale factor. Again, there is some additional vocabulary if you choose to look at that on your own. You can find that by researching transversal parallel lines. But this should be enough information to get you working and finding success on question 17.